Hi, so today my friends and I will be teaching a lesson about black holes. So what exactly constitutes a hole in our universe? When we think of a hole, we think of it as a region of empty space that object can fall into, like this hole in this piece of paper. But that's only true in a 2D dimension. Space itself is a 3D dimension. Hence, we can't really think of a hole in space the same way as we think of a hole in a 2D plane. But if we define a hole as a point where objects can fall into or be sucked up, then in space anything that has gravity can be called a hole. But I just call it a depression or a shallow pit, because with the right escape velocity and energy, objects can still escape the hole. But black holes can be considered holes because they have an escape velocity greater than the speed of light. So anything that wanders in will never be able to escape and forever be unretrievable.
Hello guys, today I'll be talking about the theory of black holes. So what exactly are black holes? Black holes are points in the space that are so dense they create deep gravity sinks. Beyond a certain region, not even light can pass through the powerful tug of a black hole's gravity. Anything that ventures too close, be it a star, planet or spacecraft, will be stretched and compressed like putty in a theoretical process known as spaghettification. Another interesting question that we can talk about is how black holes are even formed in the first place. The most common known way a black hole forms is by stellar death. As stars reach the end of their lives, most will inflate, lose mass, and then cool to form white dwarfs. When the largest of these fiery bodies, those at least 10 to 20 times as massive as our own sun, are destined to become either super dense neutron stars or so-called stellar mass black holes. What are the different types of black holes? There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. So many of you might be wondering, why are black holes called black holes? This is not a dumb question at all. In fact, I dare you say you might have a better intuition than many filmmakers. The name black hole dates from the 1960s when work on general relativity showed that a massive enough object will collapse down to an infinite point due to the effects of gravity. At some distance from this singularity, the escape velocity is equal to the speed of light. And since relativity says that nothing can travel faster than light, once anything passes within this distance, it cannot escape. The whole label is a partly result of this idea, that nothing can escape from it. It is simply sucked in and can never get out, like a bottomless pit. The description of it as a whole also refers to the existence of a singularity at the center of the event horizon. Since at the singularity, the laws of physics breaks down, and so it is in some way a hole in space that we cannot describe. Next, we will be talking about the swirling vortex effect. Let me show you guys an illustration of how a swirling vortex effect looks like. Swirling vortex effect is not only observed in black holes but also on Earth during natural disasters such as tornado and cyclone. This effect is often used to indicate the presence of a black hole is partly the result of the fact that it is rather difficult to represent a spherical piece of absolute nothingness, particularly against the black background of space. Now that modern computer graphics are better, we can show the presence of a black hole by the distorting effect it has on light, which passes near the event of horizon but does not cross it. Most material that approaches a black hole won't do so head-on, but from an angle and will, and at least initially get trapped in orbit around it rather than falling straight in. When there's a lot of material approaching the black hole, the material will all collide with each other and find a mutual direction of rotation, forming a disk. That disk, viewed face on, looks rather like the swirling plug hole, though material then falls in from the inner edge of the disk rather than from the top or bottom.
So how does scientists detect the presence of a black hole? So basically, there are three methods: gravitational lensing, accretion disk, and Hawking radiation. So what is a gravitational lens? Gravitational lens is a distribution of matter between a distant light source and an observer that is capable of bending the light from the source as the light travels towards the observer. The effect of the mass in the center that essentially bends the light as it passes close to it. The gravitational lens produces a maximum deflection of light that passes closest to its center, and a minimum deflection of light that travels furthest from its center. Next is the accretion disk. An accretion disk is structure formed by diffuse material in the orbital motion around a massive central body. There is a disk that surrounds the black hole and is essentially formed by diffuse material in orbital motion around a massive central body. As the diffuse material, or in other words, matter, enters the accretion disk, it follows a trajectory called a Tendex line, which describes an inward spiral. There's also two massive jets that is in the center of the accretion disk, which are very highly radiated particles that are projected into the directions. All of it are visible lights or X-rays or gamma ray radiation and are very bright. And lastly, Hawking radiation. A black hole thermally create and emit subatomic particles known today as Hawking radiation. Hawking radiation is a black body radiation that is predicted to be released by black holes due to quantum effects near the event horizon. The strong gravitational field around a black hole can affect the production of matching pair of particles and antiparticles, as it is happening all the time in empty space according to quantum theory.
Many of us neglect the importance of black holes in our lives. But why are black hole studies so important? Black hole studies are super important because black holes have the power to create, sustain and destroy anything in the universe. Create and destroy simply just mean transform. They are observed to be the most massive, powerful and luminous objects in the entire universe. If they weren't so gravitationally powerful, and if they allow light to escape constantly, they'll always look like the brightest stars in the universe, and we'll see them with our own eyes in the center of almost every galaxy. So black holes has also played an important part in our daily lives, such as in the use of entertainment. Many filmmakers use the concept of the theory of black holes to entertain us and also to educate the members of the public on how the theory of black holes is important. This actually creates an eye-opening experience as people are able to know more about the theory of black holes. Movies that have talked about the usage of black holes are movies such as Interstellar and Transmission. And on that note, I would like to thank you all for your kind attention in watching our video. We hope that you have learned something. Thank you.